Hello?
Yes, sir.
My screen is visible, na?
Yes, sir. It is visible, sir. Yes, sir.
First question was about the evolution of gases. Like any other two reactions you have to write for the evolution of gases other than this hydrogen gas. So have you done this?
Yes, sir.
Aditya, you say one chemical reaction for this evolution of gases other than hydrogen. Okay, start.
Sir, for the calcium oxide, sir.
Sorry, I can't hear you loudly.
Calcium oxide, sir.
So like calcium oxide is getting reacted with whom?
Uh, Sir, calcium oxide reacts with oxygen, sir.
Calcium
So
oxide
it
is saying that will react with oxygen. Means CaO, it will react with oxygen. So what it will form?
calcium carbonate.
No. Rubadinesh, you say? Any reaction?
Sir, I thought we should do only the balancing the equation. I forgot about this one.
Sanjit? Sanjit, you have done the homework? The work that I have given yesterday? Evolution of gases, I have said not to write one or two reactions for the evolution of gases in which the gases is formed other than this hydrogen gas. Sanjit, I am asking you, have you done the work?
Sir, can you hear me, sir?
Yeah, your voice is clear.
Sir, sodium sulfide plus hydrochloric acid gives sodium chloride plus water sulfuric dioxide.
Can you say it again?
Sir, sodium sulfide plus hydrochloric acid gives sodium chloride plus water plus sulfuric dioxide.
Okay, any other example?
Sir, another example is sodium sulfide plus hydrochloric acid gives sodium chloride plus hydrogen sulfide.
So hydrogen sulfide is in gaseous form or any other form?
Gas form, sir.
Okay. See, one more reaction I'm saying, nitric acid, or you can say the calcium carbonate is getting reacted with hydrochloric acid. Just write the reaction for evolution of gases. Calcium carbonate, you know the formula of calcium carbonate?
CaCO.
Yes, sir. CaCO, sir.
CaCO3. So calcium carbonate is getting reacted with hydrochloric acid, HCl. So what it will form? Any guesses? Aditya, can you say the answer? If
Sir,
the calcium
CaO plus,
carbonate is getting reacted with the hydrochloric acid, so what will be the products?
Sir, CaCl plus hydrogen, sir. Hydrogen gas.
Sanjeet, you?
CaOH plus H2.
Rubadinesh, you?
CaOH twice plus H2.
See the main reactions like in this, it will form. First is the calcium chloride. If calcium carbonate is getting reacted with HCl, it will form calcium chloride. Okay. And carbon dioxide, it will also form. You have written the reactions? This reaction you have written?
Yes, sir.
So see, yesterday we completed the balancing of a chemical equation. In that you have any doubt like it's not particular to it's not a particular rule for balancing the chemical equations. Like only one rule is not there to balance a chemical equation. Yesterday I said first balance the oxygen. After balancing the oxygen, you have to balance the hydrogen. After balancing the hydrogen means most of the time you will get other elements will get balanced from that only.
Sir, I have doubt in the balancing equation for second question, sir.
Your sound is not coming, Aditya.
Sir, can you hear me?
Yeah.
Sir, for the second question, I don't know, sir. Balancing the equation yesterday's homework.
Balancing, you are getting confusion.
Only in the second question, sir.
What you said?
Sir, for the balancing the equation, second question, I don't know, sir. I don't
Second
understand.
question. Wait, let me see. I will tell you the answer. The second question was SiCl4 plus H2O after getting reacted with each other. This question, na?
Yes, sir.
So in this, first see the number of atoms on both sides. So the reaction is SiCl4 plus H2O. It is getting reacted and it is forming H4 SiO4 plus HCl. So first you see the
Sir, can you repeat that again, please?
So Aditya, one doubt in second number question. So the second number question for balancing the chemical equation. So SiCl4 plus H2O. It is getting reacted and it is forming H4 SiO4 plus HCl. So you have to balance this. So first count the numbers of atom on both sides. So first see the Si. On the reactant hand side it is 1 and on the product hand side it is 1. Chlorine is 4 on the reactant side and on the product side it is only 1. Then hydrogen is 2 on the reactant hand side and 5 on the product hand side. Then oxygen left. So oxygen is only 1 in number on the reactant hand side, but 4 on the product side. So what you have to balance first? Silicon is balanced, chlorine you have to balance, hydrogen you have to balance, and then oxygen you have to balance.
Yes, sir.
Okay. So
Mm.
first balance the so here what you do now, first balance hydrogen. See on the product hand side, it is 5 in number. Hello?
Yes, sir.
Just wait for 2 minutes. I will share on the screen only, okay?
Okay, sir.
See, I'm writing the equation on the screen. Side. See here, first in this reaction now, first you balance the chlorine. Like it's not particular, you have to balance the hydrogen, oxygen, anything you can take, whatever it will be easy for you now. So see here, on the reactant hand side, it is 4 in number. This side, it is 4 in number. And on this side, it is only 1 in number. So if you will write here 4, okay. So here the chlorine is balanced now, 4 on the right hand side and 4 on the left hand side. After writing 4 there, you will see the hydrogen atoms number on the product hand side, it is changed. What is the number of the hydrogen, total number of atoms? 4 plus 4, that is 8. And on the reactant hand side, it is only 2 in number. So just balance this hydrogen. So for balancing, if you
So
will
we
write
write
here,
6, sir.
if you will write 4 here, okay.
Sir,
So,
it will get multiply, sir.
sorry.
Sir,
Yes, Aditya, ask what you were asking.
Sir, we put 4.
this one will get multiplied to this one, sir.
Yeah, 4 into 2. That will, if I'm writing 4 there, so 4 into 2 it will be there. It's not 4 plus 2. Okay, when you are writing just adjacent to the hydrogen atom now, you are getting, means you are multiplying the numbers. 4 into 2, that will be 8 in number. 4 to 8.
Sir, we put, sir, we
Sir, I
we
thought
write
this
4.
will add to this one, sir.
No. That is incorrect. Okay, when you are writing just adjacent to the hydrogen atom there, it will be 4 into 2. It's not 4 plus 2. Understood?
Oh, yes, sir.
So this is very important. Like in every reaction, you have to keep this in your mind. You have to, when you are writing 4 there, any adjacent atom number you are writing, so there you have to multiply. Okay. After writing,
Okay,
sir.
after writing 4 here, you will see that hydrogen is balanced, chlorine is already balanced. Now you have to check the number of oxygen. So on the reactant hand side, it is 4 in number. And on the product hand side, it is 4 in number. Means after writing 4 there, the oxygen is also get balanced without doing anything.
Sir, one doubt, sir. What is this one, sir?
Okay, wait.
See,
It's not there, okay? Just leave that.
yes, sir.
Sir, we put 4 in reactant side because in product side we have put 4 in hydrogen. So,
Can you repeat, Sanjit, what you said?
sir, in reactant side now we put 4, no, sir.
Yeah.
H2O. We put there, we write 4 then because in product side we have put 4 in between hydrogen.
You have earphone or something, like your sound is not clear.
Sir, now it is okay, sir.
Ask
Sir,
Sanjit what you are
Can you
asking.
hear me, sir? Sir, you put 4 in reactant side because you write 4 between you are write 4 in a product side, sir, in
Yeah.
between hydrogen.
So you're asking that why I've written 4 there.
Yes, sir.
See, what I said here, first just balance the chlorine atom, right? See here, on the reactant hand side, it is 4 in number. Chlorine, you can see 4 in number. Here, chlorine is only 1 in number. Because of that, I have balanced the chlorine atom by writing 4. Okay. After writing 4, the chlorine is balanced now. You can see the number of atoms on both hand side.
Yes, sir.
Now, after this, see the number of hydrogen atom on both sides. On the product, it is 8 in number. 4 plus 4. And on
Sir,
the
can you repeat, sir? Sir,
Huh.
can you repeat, sir?
See, after balancing the chlorine, you have to balance hydrogen atom. Okay, so for that, you check on which side the number of atom is more of hydrogen. So here you can see on the product hand side, 8 number of atoms are there of hydrogen atoms. Okay, like this side you can see 4 and 4. So 4 plus 4, 8 is there. Understood? So this side you have to balance by writing the numbers because it's already 8 this side on the product hand side. So you have to increase the number on the reactant hand side. So what you will write? 2 is already there on this hydrogen. So just you have to write the 4. So 4 to the 8. So on both sides, hydrogen is also balanced. Sanjit, you are getting what I am saying?
Yes, sir.
So till now you have any doubt?
No, sir.
So now chlorine is balanced, hydrogen is balanced. So after that you will see oxygen atom. Oxygen atom is 4 in number on the reactant hand side and 4 in number on the product hand side. So it is already balanced. No need to balance this. And silicon is also balanced. 1 on both hand side. Understood?
Yes, sir.
So any other doubts in the questions like whatever I have said?
No, sir.
No, sir.
So I'm continuing the chapter.
Yes, sir.
So after balancing, what you have to see now, like you have to show there what are the states of the chemical reactions or what are the states of the compound in that reaction. Okay, like if you are producing, if their gas is producing, you have to write it as a small g in the bracket. Okay, like here you can see if the compound is in liquid state, it will be small l in under bracket. If the compound is in solid state, you have to write small s under the bracket. And if the solution is aqueous solution or the compound is having a aqueous solution, so that will be written as AQ small under the bracket. Okay. So this thing also you have to keep in your mind after writing a balanced chemical equation.
AQ means
AQ means aqueous.
solid plus liquid, no, sir.
Sorry?
Solid plus liquid.
No, it's not like aqueous solution. AQ means it will be more fluid in nature. Like you can say the water and sugar solution. It is aqueous solution.
Sir, like it is a mixture of solid and liquid.
Yeah, you can say in that solution precipitate should not be there. Okay. Aqueous solution means just you have to see precipitate should not be there. Any aqueous solution like salt water, salt sugar or salt or anything that is getting mixed, or you can say water and milk, that is also aqueous solution. Understood?
Yes.
Yes, sir.
So this is all about your chemical equation. Okay. So just write the last.
Sir, sir, after the next week, I have a unit test, sir.
Unit test
Yes, sir.
for
In
this chapter.
chemistry, from introduction to decomposition reaction, sir.
Can you say loudly what you said?
Sir, my chemistry portion is introduction to decomposition reaction, sir.
Sir, next week I'm also having a test, but on acid bases and salts.
Just wait. I will connect my headphone. Okay, your sounds are not clear. Just wait for 2 minutes. I'm coming. Hello, my sound is clear now?
Yes, sir.
Sir,
What you were saying?
Sir, sorry, sir, network issue. I left the meeting, sir. Sir, can you hear me?
Yeah. So Sanjeet, you are having a test for this introduction to decomposition reaction.
Yes, sir.
Okay, today only we will see this decomposition reaction. And Rupa Dinesh, what you were asking?
Okay.
sir, I was telling that I'm having a test on acid, bases, and salts Monday or Tuesday. Tuesday, I guess.
Okay, this Tuesday.
Yes. This Tuesday.
Okay. No problem. After this
Yes.
test only, we will start the acid base. Okay, or a quick revision if less time will be there, na. So we will do a quick revision of that chapter for your test. Okay.
Okay, sir.
So today we will start the types of a chemical reactions. Like what are the types of chemical reactions that occur?
Sir, they are four types: combination reaction, decomposition reaction, displacement, double displacement.
So these are the types of chemical reactions that you have in your syllabus. Okay. So first is the combination reactions. Like combinations reactions are the one in which you can see like two or more reactants will be there. In that, the reactant will combine with each other and it will form a single product. Okay, like there are many examples you can see. Like on the screen only you can see magnesium is getting reacted with the oxygen. The magnesium is in solid state, oxygen is in gaseous state. They are getting reacted with each other and it is forming a single compound. That is magnesium oxide. Okay, you can see on the screen it is a balanced chemical equation with their particular states. Okay. So combination reaction is nothing, just a reaction in which two or more reactant will combine to each other and it will form a single product. And that will be known as combination reaction. There are many examples. Two of them are on the screen. You can see. First one is the magnesium and oxygen. They are getting reacted and it is forming a single product. That is magnesium oxide. Second is the carbon is getting reacted with the oxygen and that is producing carbon dioxide. Got it? Any doubt in this combination reaction?
No, sir.
No, sir.
Just copy the definition and two examples that are written there. Just write the equation. Don't write complete. Just write the definition and two examples of magnesium and carbon. So we want X, how much we will take X, so after adding we will feel. How Done?
Yes, sir.
Sanjeet, you switch on your camera.
Sorry, sir, I had a network issue.
After completing, just say done or not. If the meeting will end, now just join with the same link, okay? Immediately join with the same link.
Sir, should we join in 2 minutes or the next second it ends?
Yeah, just take break for 2 minutes. After that, you can join. Together and it will form a single
Yes.
product. Okay, so next, you can see decomposition reaction. Like decomposition reactions is also a type of a chemical reaction in which the one compound decomposes into two or more compounds or elements, you can say. Like you can say this is just opposite to the combination reaction. In combination reaction, it was like two reactants are getting reacted with each other and forming a single product. Here you will see single reactant will come and it will decompose into two more product. Okay, in the example you can see calcium carbonate. Calcium carbonate you can see here.
Sir, calcium carbonate is also known as quicklime.
What you are asking? Calcium carbonate?
It's also called as quicklime, sir.
You are asking about the other name of calcium carbonate?
Yes, sir. It is quicklime, sir.
Hello? What you are asking? Just your sound is not clear. Okay, see, we will see the reaction. Here you can see the calcium carbonate is getting decomposes into two products, calcium oxide and carbon dioxide. Okay, see, so here you can say the name of this carbon dioxide. Yesterday I gave you work that evolution of gases. Here you can see other than hydrogen gas is evolving. Calcium carbonate is getting reacted with heat and it is decomposes into calcium oxide and the carbon dioxide. Second example you can see FeOH whole 3. Can you say the name of this? Any one of you?
The name of what?
FeOH whole 3, the second
The
example
name
of this decomposition reaction.
Sir,
Ferric
ferric
hydroxide.
hydroxide.
Ferric hydroxide. So ferric hydroxide, here the heat is given. After providing the heat, it is getting decomposed into Fe2O3 and H2O. So in this reaction, you will see only single reactant will be there. That single reactant will form two or more products. In the examples you can see. One example, one type you can say of this decomposition reaction is given thermal decomposition. Like when you will use heat in any reaction na, that reaction will be known as the thermal decomposition. Okay. So here the thermal decomposition example you can see PbNO3 whole 2. Here the heat is provided and it is forming PbO and NO2 and oxygen gas. So here you can see three products are forming. Single reactant is there. That single reactant is getting decomposed into three products. So just write the example and you can write type of this decomposition reaction. Thermal decomposition, and second one I will explain you electrolytic decomposition. First write this two. Just write the definition, then the chemical
Sir.
equation. Yes, Sanjit, what?
Sir, can you hear me? Sir, what is the name of PB, sir?
PbNO3 NO3 whole 2 that you are asking.
No, sir, the name, that symbol.
Sir, is that ferric? No, PB lead nitrate, sir.
Yeah, lead nitrate. The name of this compound is lead nitrate.
Okay.
You are asking the same question, Sanjit?
Yes, sir.
Okay,
Yes, sir.
okay. Just write the reactions.
Sir, is that correct, sir?
Yeah, it's correct.
Okay, sir.
Can you say like if instead of NO3, if it is NO2, so what will be the name of the compound?
Nitrate, sir.
Sir, lead, nitrate.
Yes,
Lead
Sanjit, say.
nitric.
Ruba Dinesh, any guesses for this question? Like if
Lead
instead of
nitric or nitrous, sir? Lead nitrous.
no.
No.
See, the name will be lead nitrite. For nitrite, you will write NO2, and for nitrate, you will write NO3. So that is the difference between nitrite and nitrate.
Okay, sir.
So
Sir,
next
is there any PbNO?
PB,
NO,
that will be nitrous.
nitrous. Okay, sir.
Sir,
Sir,
completed, sir.
sir,
Done na?
sir, one doubt, sir.
Ask.
Sir, in the textbook, actually, they have given about an example, no, sir, for photolytic, sir. Sir? Hello?
Hello? Yeah, Aditya, say.
Sir, can you? Yes, sir. Sir, in the textbook, they have given an example, no, sir.
Yeah, say the example. What
Sir,
is it?
about the silver bromide, sir.
Silver bromide.
Yes, sir, kept outside in the sunlight. Sir, that my chemistry sir told that it does not mainly comes under the photo decomposition, sir. It comes under thermal decomposition as it occurs exothermic reaction, sir.
See here what is happening now, like
Sorry,
that-
endothermic reaction.
see here what is happening, the sunlight is getting used, so it can be said as photolysis also, and this thermal decomposition also, because the sunlight will provide the heat only, so on the basis of heat only it will get decomposed. Getting what I'm said?
Yes, sir. Yes, sir.
Hmm.
So
Thermal
for both example, this can be written, sir.
Yeah, see that it's there in the PDF only. See photolysis. On the top of the screen, you can see photolysis or photo decomposition reaction. Okay. Like if the sunlight will be used, reaction in which a compound decomposes because of the sunlight, that you have to set as a photolysis.
Okay, sir.
Okay. After this thermal decomposition, one more is there, electrolytic decomposition. Here the electrolytes, or you can say electricity, will be used for the decomposition or for the breaking of a compound. Okay. So the reaction in which the compound decomposes into the simpler compound because of passing of electricity, and that is known as the electrolytic decomposition. This is also known as electrolysis. Like by the use of electricity, by passing the electricity, the reactant will get decomposed and it will form the other products. Like in the example, you can see water molecule is there. Water molecule is getting decomposes into hydrogen and oxygen. Understood?
Sir, can you repeat?
Sir.
So I'm saying like the other type of this decomposition reaction is electrolytic decomposition. So previously thermal decomposition was there. So there we were using heat. After that, using of heat only, the compound is getting decomposed into the products. Just like here, instead of heat, we will use the electricity. Like we will pass the electricity from that compound. After passing, that compound will get decomposes into the other products. Example you can see. H2O is getting decomposed when the electricity is passed and it will form hydrogen molecule and oxygen molecule. Understood?
Yes, sir.
So just copy the electrolytic decomposition,
Yes,
just
sir.
definition and that example.
Copied.
So the next is that photolysis. Photolysis means instead of this electricity and heat, we will use the sunlight. Photo means you can say the sunlight. So the sunlight will be used for decomposition. So one example is given there, AgCl. If we will provide sunlight, it will form a Ag that will be gray in color in the solid form and it will form a chlorine gas. Understood? So till now you have any doubt in the decomposition reaction? Till now you have any doubt in this decomposition?
No, sir.
No, sir.
So the next is
No, sir.
displacement reaction. So this is the third type of the chemical reaction. So what will happen in this now? One element will displace another element from both the side. Like example, you can see zinc is getting reacted with HCl. After the reaction, you will see with HCl, zinc is there instead of hydrogen. Okay. Like here you can see, wait. Initially, hydrogen is there. The zinc will displace this hydrogen and it will take the place of hydrogen. And in the product side, it will form zinc chloride. So the reason for this change is you can say it will be less reactive. Like the more reactive element will displace the less reactive element. Understood? So hydrogen is less reactive here and zinc is more reactive in comparison to the hydrogen. So zinc will displace the hydrogen place and it will take the place and it will form another compound. This reaction is also known as substitution reaction or replacement reaction, you can say. Like one is substituting the other now. That's why the name is given. Understood this displacement reaction, what exactly it is?
Yes, sir.
Yes,
So
yes, sir.
just, write the definition and write the examples, whatever it's written there on the screen. Last reaction you can also see, zinc is getting reacted with copper sulfate. After the reaction, zinc is displacing the place of the copper and it is forming zinc sulfate and copper. Done?
One minute, sir. Done, sir.
Okay, we will see the next reaction. That is double displacement reaction. See, the same thing is there, but here two displacement you will see. Example you can take barium chloride, that is BaCl2. It is getting reacted with Na2SO4, that is sodium sulfate. After the reaction, you can see the barium place is getting displaced with the sodium atom. So it is forming barium sulfate. That will be a precipitate in the solution. And sodium chloride. So the reaction in which ions are exchanged between two reactants. Two reactants are there. They both will change their place. And it will form a new compound. That you will call as double displacement reaction. Understood?
Yes, sir.
So another example is there, sodium hydroxide. It is getting reacted with HCl. After the reaction, you will see the sodium will take place the hydrogen place and it will form sodium chloride and H2O. So this is double displacement reaction. Just you keep in your mind one single thing in this reaction. If in double displacement reaction, a precipitate is forming, then that reaction is also known as precipitation reaction.
Sir, in this two reactant displaces another less reactant, sir.
Yeah, the more reactant, the more reactive element will displace the less reactive element.
For the displacement, it is same, but it only happens for one. But in this, it happens for two.
Yeah, it will means two compounds will be there. And both the compounds, the atom will exchange their places.
This always form a precipitate.
Sorry, what you said, Rubadinesh?
Does this double displacement reaction always forms a precipitate?
No, it will not always form precipitate. If the reaction is forming the precipitate reaction, you can say it as a precipitation reaction. But in the second example, you can see sodium hydroxide is getting reacted with HCl. So it will form NaCl. Here you can't see any precipitation reaction. Got it? Another example you can see that particular precipitation reaction is written there. In that, the silver nitrate is reacting with the sodium chloride and it is forming a precipitate, that is silver chloride, AgCl. and sodium nitrate. So this you can say it is a precipitation reaction.
Okay, sir.
So just write the definition and write the two examples and this type of this double displacement reaction, precipitation reaction.
Sir, finished.
Done?
Sir, done, sir.
Can I change the slide?
Yes, sir.
Yes,
So one more example is there, neutralization reaction. Like in this, the precipitation will not be formed. Same as that, here it's written NaOH and HCl and it is forming NaCl. Same, it is a neutralization reaction. So the next is the oxidation and reduction reaction. In this, two things are there, oxidation and reduction. First is the oxidation. So what will happen in the oxidation now? Addition of oxygen or non-metallic element or removal of hydrogen. That will be known as oxidation. Or you can say element or compound in which oxygen or non-metallic elements is added. When you are adding oxygen to any element now, then it will say that element is oxidized. So oxidation is taking place. Understood?
Sir,
Any doubt, Aditya?
sir, for after the oxidization reaction only, sir, the rancidity and the corrosion happens.
Yeah, oxidation process happens in that rancidity only. And corrosion also it's happening because of the oxidation reaction. The iron is getting reacted with the oxygen. So you can say in iron, oxygen is getting added. So definition you can see addition of oxygen. That is the oxidation process.
Okay, sir.
Understood? Wherever you will see now, like one single atom is there. Suppose, wait, I
Sir,
will.
in the combination reaction we saw no, sir, like in the magnesium ribbon, the oxygen gets in the upper layer of that.
Yeah, here you can say that it is getting oxidized. Magnesium is getting oxidized on the screen you can see.
Okay.
So this is an oxidation reaction you can say. Wherever you will see, like the oxygen is getting added. So that you will consider as a oxidation process. Understood?
Yes, sir.
yes, sir.
Or one more definition you can see, removal of hydrogen or electron you can say, loss of hydrogen. Suppose if a element initially it is having a hydrogen and after the reaction it is not having the hydrogen there. So that element you can say or that process you can say oxidation happens. So in oxidation, two things are happening, addition of oxygen and removal of hydrogen. If both are happening, you can say, or any one of this is happening, you can say oxidation is happened. Next is the reduction.
Okay.
Just opposite to this, oxidation. Addition of hydrogen or removal of oxygen. That will be known as the reduction process. One example I will show you, wait. See here, the copper oxide CuO is getting reacted with the H2. After the reaction, it is forming copper plus H2O. So you can see on the reactant hand side, oxygen is there with the copper. But in the product, oxygen is not there. So reduction happened with the copper oxide. Initially, the oxygen is with copper, but after the product formation, oxygen is not there. Understood?
Yes, sir.
So after oxidation, and first write the definition of this oxidation and reduction.
Sir,
Yes,
can you
Sanjeev?
repeat, sir? Sir, can you repeat, sir, what you told now?
Sorry?
What you told now, sir?
I can't hear you. Say loudly. Sanjeev, you are saying something?
Sir, can you hear me, sir?
Yeah, now your voice is clear. Say whatever you are saying.
Sir, what were you telling, sir?
I was saying for the oxidation and reduction, see here. One reaction is there. Here you can see on the screen, one reaction is there.
Yes, sir. Yes, sir.
Copper is having oxygen here, okay? Copper is having oxygen. But after the reaction, you can see copper is not having the oxygen.
Yes, sir.
So here you can say this compound, copper oxide, is reduced. Okay. Reduction process happened here. You can see the definition
Okay.
of the reduction.
Removal of
Oxygen. So that is the reduction process. Understood?
Okay, sir. Yes, sir.
And just like the Aditya said, like in the combination reaction, the oxidation process was there. Magnesium is getting reacted with the oxygen. So that is the oxidation process, because in that oxygen is getting added. Understood?
Yes, sir.
After this oxidation and reduction, two more things are there: oxidizing agent and reducing agent. So they are like, oxidizing agent are the one that they will do this oxidation process. If a compound is there and if it is doing the oxidation process, means it is giving oxygen to the other compound, then that will act as the oxidizing agent. Here, can you guess, in this reaction only, copper oxide and hydrogen, which one is oxidizing agent? Any guesses?
Sir, H2.
Any
Sir?
guesses from other?
Sir, H2 is
Sir, can you
oxidation
hear-
reduction as well as a
Hydrogen.
reducing agent.
Hydrogen, sir.
See, the definition of oxidizing
can you
agent
hear
is, the definition of oxidizing agent is the substance which will give oxygen to other compound. So in this reaction, who is giving the oxygen to other compound?
CO. CO is the oxidizing agent.
Sir, so copper
Sir,
oxide is
H2 is saying,
copper oxide is providing the oxygen to other compound, that is hydrogen. So copper oxide is acting as a oxidizing agent. Understood?
yes, sir.
So last, here you can see, like, see this 2 point, last 2 point, this and this. By this you will get clear answer. The substance which gets oxidized is reducing agent. The one who is getting oxidized that is the reducing agent. So here hydrogen is getting oxidized now. This hydrogen is getting oxidized by gaining the oxygen. Okay. So hydrogen is reducing agent, and the substance which gets reduced is the oxidizing agent. Here you can see the copper oxide means the copper is getting reduced to copper. This copper oxide is getting reduced to copper. So here this CuO is the oxidizing agent. Understood?
Yes, sir.
Any doubt? Aditya, Ruba, Dinesh, Sanjeet, any doubt in this oxidizing agent?
No, sir.
Oxidation?
Yes, sir. No, sir. No, sir. No, sir. Sir, can you hear me, sir?
Yeah, I can hear you.
No doubt, sir.
Sir, so this week fully chemistry, sir.
Yeah, this week, like after completing the chapter only, we will see, like we will update you.
Okay, sir.
So next is your exothermic and endothermic reactions. Like this is a simple, like if a reaction is releasing something, releasing a energy or releasing a heat, that will be known as exothermic. Exo means to come out, and endo means in that reaction, the energy will required. Understood? So the exothermic definition, you can see the reaction which produces energy is called the exothermic reaction. Just join the same link after the meeting will end. No, just join the same link immediately. We will have 2 minutes more, 5 minutes more. After that, the chapter will be completed only.
Okay, sir.
Okay, sir.
So in exothermic, you can see the energy is getting produced. 2 examples are there on your screen. So these are the exothermic reactions. Next, you can see this endothermic reaction. Heat is getting used. So this is the endothermic reaction. Like the thermal decomposition, you can see there. Here, there you were using the heat. So that is the endothermic reaction, you can say. Wherever the heat energy is provided,